And welcome back to Creative Thinkers. Again, my name is Miguel, and as always, we bring you a very special guest. Today we have somebody that is at our school here at EPCC. Today we bring you Teslin Chaney, and she is a professor of biology. We're going to talk about a whole bunch of fantastic things. Tess, welcome.
Thank you for having me. Any excuse to talk about biology, I'll take.
And it's a great subject, right? Mm-hmm. So the show is called Creative Thinkers, and we want to make these connections. But before that, I want to get to know you a little bit so our audience can sit here and kind of understand what kind of connections you have and why in the world you do what you do. So how was your childhood? What was your upbringing like? How in the world did you make this connection to all of these lizards and snakes and all of that?
Yeah, absolutely. So growing up, my dad was into biology. He was a professor specifically on reptiles and amphibians. So I've always been connected to that area. My mom was an artist, so I always felt like I had the best of both worlds kind of growing up, because I always was connecting art to science in almost everything that I did. But yeah, so that love for animals and biology has just pretty much followed me throughout my entire academic career. And so, yeah, that's what I've spent most of my time on.
How did you decide between art and science?
I didn't. In my undergrad, I was biology major, art minor.
Oh, really? So it's always been that connection.
I always tried to connect the two because there are so many connections to be found. And so I always wanted the best of both worlds. I always wanted to incorporate art into my science as much as possible and that creativity. So yeah, I did the best of both worlds. I did scientific illustration as my minor, so I tried to kind of depict the anatomy and physiology of certain biological concepts and species, and that's what I worked on. But yeah, it's always been both for me.
So up until a couple of years ago, I didn't know that this was a thing, but apparently there's archaeological rendering or something like that. I don't even know what it's called, but one of my students did a project on that, and she said, I want to actually become an individual that draws dinosaurs, which is another thing that exists, which I didn't even know. So I guess most of it is conceptual. Did you always make that connection through art and science? Were you actually drawing these reptiles out?
Yeah, so I always started with drawing just as a child. Like I would always draw animals, my animals, certain things that I saw, trees, plants, flowers. And then I realized through going to college that I could incorporate that more through scientific illustration. So that's what really turned kind of a creative side project into more of a mainstream focus for me. I never was into dinosaurs, so I didn't draw any any dinosaurs, which is a very fun field because it's extremely creative.
Yeah, it's kind of all conceptual, right?
It's all conceptual. You're just kind of using inspiration from, things that are here and now to make decisions about what things might have looked like back then. So really cool field on that one. But yeah, so I would draw some of the scalation in the snakes that I worked with. I would, do a diagram of something, So I did a lot of illustration for my projects and just for personal fun.
And that's awesome that you had that connection even as a kid. But there is a deeper connection between this concept of creativity and what biology is. And that's one of the things that I don't think that most of our audience understands, that all of these ideas and concepts are connected, from mathematics to science to fine art or actual art. And that's what I want to talk a little bit about. I want to ask you, how in the world, aside from you actually making drawings and making those into these kind of scientific models, how is science creative?
Yeah,
or biology specifically?
Science and biology, absolutely a creative process. I think creativity is probably one of the most underappreciated aspects of science and biology, but I think it's truly the difference between a good scientist and a great one, is this ability to create, this ability to think and dream, innovate, think outside of the box, place connections, put puzzle pieces together where nobody else might have put two and two together. And that's the difference between, someone who just kind of sticks to the rigidity of the scientific method. This is what we have to do, process A, B, C.
And there are different types of scientists in that world where one might want to kind of stick to, I don't want to say the status quo, but stick to the way things are done. And then there's others that are like, there's more there. How can I figure this out?
Absolutely. And you can still be a great scientist if you want to stick to what's already there, right? But the people who are making innovations, those are the ones that are thinking creatively. You know, the first step of the scientific method is ask a question. And that, and step 2, which is form a hypothesis, basically make a guess. That's where a lot of the creativity comes in, right? You have to observe the natural world. You have to think creatively. Why does this happen? What's going on here? This is what I think's happening. This is my explanation for it. And that creative thinking can be really hard. It's really hard to do that, to put those pieces together and think creatively. And that's why I say it's kind of underappreciated, because you can stick to the status quo and still be a great scientist. But you miss out on the innovations, the next generation of things that we have no concept of now, if you get rid of the creativity from the process.
And that's what we have to deal with every single day as artists. When we're creating something, we have to figure out what we're inspired by, right? And then take that and mold it into something completely different. Like, for example, we had talked a few days back about, not Einstein, who was it? Sir Isaac Newton.
Isaac Newton,
and
yes.
how in the world Sir Isaac Newton made these connections through creativity and what he was able to find. But give us a whole bunch of other examples so we can have a better understanding.
Yeah, he was a great one. He came up with, you know, the idea of gravity, which again, that was wild at the time. Definitely some out of the box thinking. The one that always comes to my mind is Nicholas Copernicus. He was the one who thought of essentially getting rid of the Earth as the center of the universe, and instead thinking of this heliocentric model, meaning our kind of solar system revolves around the sun. So prior to him, it was believed that Earth was the center of the universe, and this was kind of religious in nature because, you know, humans, we're kind of we tend to place ourselves in the center of things. So when he came up with this heliocentric model, it was truly a revelation. It was somewhere that nobody else dared to go, right? Because it was kind of sacrilegious to a degree to say that something other than humans being the center of things was happening. And so that was probably about as out of the box thinking as it gets, right? Going where nobody else dared to go, putting together those connections. And now the things that we understand about our universe and our solar system and the functions of it are based on some of his ideas of this early example of something different from the status quo.
How does somebody come up with those ideas? Like Copernicus, for example, what brought on this thought process that led him to believe that the Earth wasn't the center and that in reality the sun was?
So,
because I think that when you're so used to seeing the Earth be the center of everything, how do you say, well, maybe there's a mistake here? We've got to start asking questions like, what's the catalyst for that?
It's hard. I think
and then maybe you can put it in terms of what you do.
Yeah. So I think in my kind of experience and opinion, it's curiosity. Curiosity is a big part of science, and it goes in with creativity as well. This, you know, wanting to, again, think outside of the box, but wanting to understand, right? Wanting to gain knowledge, wanting to know why the world functions the way it does. And that's kind of a common thing you'll see with every scientist. They constantly want to know why. You tell them a fact, they go, that's really cool. Why? Why is this happening? And that why, that questioning, that desire for more, the desire to understand is what really underlines all of these great scientists and the things that they were discovering, right? Is this question, why? Why does this happen? Why do we see these specific things? And then they conduct some research, they follow their scientific method, and they come up with some sort of explanation, right? Either supported or not. For mine, I was always interested in, again, reptiles, amphibians, so my big why is just understanding connections, right? How does this fit in? How does this snake fit into ecosystems? How are they related? Evolution, natural selection, changes over time. So that's the underlying, but kind of how it fits into my why.
And what's a good example, whether it be yours or some other biologist, of something that maybe didn't make so much sense, but was followed for many years, following the status quo, and how somebody had this revelation and then be like, wow, this is so different from what we did? Because one of the things that I talk to my students about is how there are these individuals who follow the status quo. 99% of the people follow the status quo. A lot of times they're maybe afraid of rattling the box a little, and they're like, maybe I think this is going on, but maybe I won't say anything. And then there's other people that are like, why not? Can you give us an example of somebody who really rattled the box and found out this amazing thing?
Yeah. One of the biggest that I can think of is a pretty famous one, Charles Darwin.
Okay.
So Charles Darwin came up with him and a few others, Alfred Russel Wallace, for example.
Were they both in the same place?
Similar areas. Alfred Russel Wallace was more of a field biologist, where Charles Darwin was a little bit more upper echelon, kind of elite scientific society. But the idea of evolution, things changing over time, that was about as sacrilegious as it gets. Because
so did we think that just things were always the same?
Prior to this idea of change, it was essentially creationism, right? God created everything. And to say that things deviated from his creation was about as sacrilegious as it gets.
Right, that makes sense.
So they came up with this idea of evolution, right? Change over time through natural selection, which is essentially survival of the fittest. But it was absolutely hated for the longest time.
And that was only like 100 years ago, right?
It was not that long ago, 1800s. But yeah, it was absolutely nose turned up. That's sacrilegious. It's not what's happening. But over time, right, with enough study, with enough evidence, now we're able to see evolution on a micro scale, like every day. The reason that we need a different flu vaccine every year is because the flu vaccine, or the flu virus, is changing. It's evolving. And that's all evolution is, change over time. It's just as simple as that. So now it is widely accepted, evolution. We know it's occurring. We can see it real time in viruses and bacteria. The real fun question is the why. Why is change happening? So that one we're still answering. That one we're still figuring out. But yeah, that's about as far away from status quo as you can get, is coming up with some sort of idea that made pretty much the entire scientific community hate you.
But that's a good thing, because now, little by little, it becomes accepted, or at least talked about, right? How does one create this open mind for oneself in order to begin to ask these questions? Because in art, and this is again another thing that I teach my students, I always tell them, a work of art is an object that will stimulate your mind. And what happens when your mind is stimulated, for example, here in El Paso, we have that big giant red X across the border. What happens is you begin to ask questions like, why in the world did they build a big giant red X? Who paid for the big giant red X? Why did they make it so big? Is it supposed to say Mexico across the border? A bunch of questions. And when we start to get those questions in our mind, then we start to look for answers. So there's like a process that begins to happen within your brain that allows you to ask these questions for yourself. Then when you ask the questions, you get the answers. Then when you get the answers, you gain the knowledge. So it makes you better. How does one as a scientist get into that frame of mind? For you, I think it might have been a little different because you had that, impulse from your mother that had that creative side, right? Do you think most scientists have that? I
think it can be something that you develop, because it's very easy to just see something, even in the scientific community, and take it for truth. And that's what you
and you're talking, sorry to interject, but you're talking about something that has already been studied and kind of proven to a certain degree?
So yes,
and then?
something that, not necessarily proven, we tend to avoid prove in science because nothing's ever proven. But something that that has been previously supported, right? Form your own conclusions on it, right? Go collect data, gather evidence, but always be willing to change your mind and always be willing to be wrong. And that can be really hard for new scientists and even new students in my classes, right? They make a wrong guess, they do something wrong, and I always say, a wrong answer is still an answer.
Yes.
And so
very true.
Keep an open mind when you're thinking about the why. Never take something for face value. Always do your own research. Always look into the facts, the evidence. Find your own support and make your own conclusions. That's what I think is hard to do as a new scientist, because you tend to think, oh, they know more than me. Like I'm just going to go with whatever that person said.
Right.
But that's how you don't get innovations, right? Just trusting somebody else blindly and not questioning their method or questioning. So always question, always do your own research, and make sure that you are still keeping an open mind throughout it all. Because I think a closed mind really makes it, near impossible.
Oh, absolutely. And, when I teach my students about Paleolithic and Neolithic, the example that I use literally is the cartoon or animation called The Croods. And I use that because a guy, the one that's a little bit smarter than the Neanderthals or cavemen, is gaining knowledge a little bit quicker than these other people. And at the beginning of that movie, the father figure comes out and says, "Never not be afraid," meaning always be afraid. And I think that fear is one of those aspects that keeps us from progressing many ways. Do you find that in the scientific community?
Absolutely. It definitely can alter kind of decision making and fear. So one example that's kind of personal to me, I really love snakes. That's my kind of bread and butter for my science. That's what I want to study, what I like. And I really was drawn towards snakes specifically because of the fear. Not that I have of snakes specifically, but you either love snakes or you hate snakes. And most people are afraid of them.
Yes.
And that fear of the unknown and that fear of a certain thing can easily turn into hatred sometimes.
Yeah, I agree with that.
And not always, but it's for snakes especially. And I think the more you understand about something, the less you fear it. And that's a lot of the goal of science, is to understand as much as we can to kind of dispel that fear of the unknown. So with snakes, that's, I try to tell everybody that I can. All the cool things that I know about snakes, right? All the cool things that I know. And it's okay to not like them, but if you can dispel some of that fear for people, I find that they're a lot more open-minded. They're like, actually, that's pretty cool. Snakes are actually kind of cool, right? And maybe if I just change one mind, that might affect some things later on.
Which snake I'm really afraid of? Those big giant yellow ones that everybody has around their necks. They just seem they just seem terrifying to me. Now, getting back into creativity and art, is color a factor in certain things, like one being more venomous than another?
Oh, absolutely.
And I think that's maybe where the fear comes in. I'm like, yellow snake, that thing's gonna kill me, you know what I mean?
Yeah, no, not venomous at all.
Really?
There's a few, you're thinking of like a python, probably a reticulated python. They are not venomous to any degree. So color is used in a whole wide variety in the animal kingdom. It can be mimicry, so you can mimic certain things. Warning colors is another example. That's probably the one you're thinking of, where you're advertising like, hey, I'm venomous, or hey, I'm poisonous, don't eat me.
And is that the case with that big giant yellow snake? No, okay.
Nope. So that's the warning colors. Think poison dart frog, right? The really bright frogs. Then there's other species that mimic those species. So they use color in a completely different way. They use it to pretend like they are poisonous or venomous.
Oh, really?
So, hey, don't eat me because I'm
That's
venomous.
my situation.
Yeah.
That's my relationship with that yellow snake.
Yep.
Yeah, I see it in Vegas, just like different places. I'm like, I'm not touching that thing. Why would I, you know?
Yeah.
And the people are like all nonchalant about it, no big deal. But yeah, I think there is a kind of fear that is associated with things like animals, but also I think there's a fear with science in general from the general public. I think that individuals are afraid to learn about this stuff because maybe they're afraid of what they're going to find out. You know, in the same respect in art and creativity, we run into the exact same problem. It's like if I don't know about it, it's kind of scary to me.
Ignorance
Do you
is
find that
bliss.
that's true?
Yeah, no, it definitely is. To some degree, ignorance is bliss. You typically don't see that quite as much
True.
in the sciences because our whole thing is trying to dispel ignorance. We're trying to know as much as we can. But there is definitely some scary stuff out there that in the sciences that it hurts to know, right? You know, it's not a good thing. Not a good thing to know, but it doesn't bring you comfort to know this thing. And so sometimes people can try to stay away from things like that. But I think, again, knowledge is the best way to overcome fear. So if you shine a light on it, if you research, if you study more, if you find a cure, it becomes a little bit less scary.
That's for sure. I think in many ways that's what creativity is about. You know, exploring, trying to find new things, trying to kind of push the envelope in many ways, whether it be in art or math or science. I think that's what we're all trying to do as individuals, as teachers, right? As instructors, what we're trying to allow individuals to understand is that we shouldn't fear these things. What do you do in your class that helps students better understand what you're trying to do through biology? Because I assume that not all of your students are biologists. So some of them are like, I'm taking this class, I want to be a police officer, and I have no idea why in the world I'm in this class. What do you do to help them understand this absolutely needs to be a part of what you do?
Yeah, so some of the non-majors classes are actually some of my favorites because I get to deal with so many different people with so many different goals and motivations. But science and biology is relevant to everyone.
Oh, absolutely.
Like 100%. It is truly biology, the study of life, right? And everyone can relate to that in some degree based on your own interests. Right? So what I usually try to do to help build those connections, first I learn my students, right? I figure out who's who, what are you interested in. But once you know that, then you can kind of tailor, hey, have you heard about this? This is a really cool.
Nice.
Have you heard about prions? Prions are really cool. You know, you can tie in their interests. And there's absolutely, in my experience, there's always a tie-in. Right? The study of life is so broad that you can find something that interests anyone.
Why do you think that they're afraid of it? What is it about what science is that people are like, you know, in the same respect, math and art? And it's, to me, it's very interesting because these are all things that as I've gotten older, when I was younger, you know, I didn't know much about that stuff. My dad was a historian, my mom was a businesswoman. So because of that, I really didn't have that much experience in reference to that. But I knew that I didn't do well in math, I didn't do well in science because I really didn't understand the deep connection of what it is. What have you found?
From what I've seen, science is a tough subject. You know, it demands a lot of you. It demands the analytical thinking, right? You have to, you know, formulate a hypothesis, steps, you know, think analytically, quantitative, do calculations.
That in itself is scary.
Yeah, so that's scary immediately. But the other side, right, the creativity is also the scary part. Forming those connections. Why does this happen? Why do I think that happens? Right, fitting the puzzle pieces together. That's also hard. So it can kind of depend on, you know, you can be more inclined to one or the other. Obviously the brain, you can train your brain to be more creative. You can train it to be more analytical. It's very what we call plastic. It can change. But that's what I find is the scariest part. It's a demanding subject, and it demands both sides. It
Oh,
demands the creativity, and it demands the, you know, quantitative analysis. So it can scare people off.
If you could change something about the way people perceive this whole idea of biology or sciences in general, what could you do, or how could you help them better understand these concepts in order for them to appreciate it more? Because I think ultimately what we're trying to do by allowing them to learn is to have them appreciate it.
Yeah, what I kind of comes back to, I think that there is a space for everyone in science. I think there is something that can interest you, and I think that should always be your starting point. Find something that you like, right? Find something that you want to talk about that inspires passion, right? If you're more creative, take it in that direction. If you're more analytical, take it in that direction. But that's where you should start, and that's always the best jumping off point. So that's where I try to get people interested. I try to give them little facts, little tidbits here and there, something that they're like, oh, that's really cool. That's really interesting. And then from there, they get their toes wet, and then they're able to kind of dive in, and they feel a little more comfortable with the topics and with the different aspects of science. So that's the best way. Find the little thing that you like.
Just try to get them into the whole grand scheme of things, right? So one of the last questions that I try to ask, because we run out of time very, very quickly here at this show, is I try to ask all of my guests if they have any piece of advice that they could give the general public. And it can be about anything in general. It doesn't have to be scientific, but if you want it to be scientific, please do so. So yeah, let us have it.
So I think I'll start with a quote from a little-known scientist, Albert Einstein.
Okay.
He said that imagination is more important than knowledge.
What does that mean? That's pretty deep.
Knowledge is limited, but imagination isn't, basically. And so what I take that to mean is, don't be afraid to dream, don't be afraid to imagine, don't be afraid to create, right? Because that is the process for innovation. That is how you innovate, that's how you inspire the next generation. Right? Imagine, dream, create, and through that, we will gain knowledge. Right?
That's absolutely true, 100%. Thank you very much. And I think it goes back to what I said about the Croods earlier. The father said, always be afraid, basically. And if we did, in turn, always stay afraid, I think we would still be in the cave. And luckily, we ended up stepping out and kind of doing our thing. So if somebody wants to take your class, what classes do you offer, and where can they take it?
Yeah, absolutely. So I am on the Mission Del Paso campus. I teach a lot of the introductory biologies, so non-majors biology. I've taught majors biology, and then I also do a little bit of the anatomy physiology side of things as well. So
which is beautiful, because we've learned a lot from you in reference to that. I think you're a fantastic individual. I love the conversation, just making those connections between art and what creativity is and how science is involved with that. But one of the things that we didn't talk about was the fact that we have drawings and molecules and all of that, and that absolutely is art as well. So I hope you enjoyed your time here. I want to thank you once again for taking the time out to talk to us, and it was a wonderful conversation.
Yeah, absolutely. Thank you for having me.
Absolutely, our pleasure. So I want to thank everybody for joining us once again. My name is Miguel Valenzuela, and you're watching Creative Thinkers. If you guys want to contact me, you guys can email me at mvalen31@epcc.edu. You guys can also find us on YouTube, so please tune in and watch our show, and we'll see you guys next time. Thank you very much.